Hey guys, Travis Gillespie. In the last video, we were looking at finding measure angles of polygons, and in this video, we're going to look at being asked how to find more measure angles of polygons. Exciting. So before we actually even get started in our next problem, let's take a look at the two polygons that we worked with before. Well, in this octagon, let's see, 1, 2, 3, 4. I had 6 triangles. Cool. I had 6 triangles inside of an 8-sided figure. Okay, so those 6 triangles multiply to give me 1080. Well, in the 7-sided figure here, I had 1, 2, 3, 4, and let's even write those down. I had 1, 2, 3, 4, and 5 triangles here. So within a 7-sided figure, I had 5 triangles. Let's even write that out. So now I'm going to say, hey, an 8-sided figure has 6 triangles, put an S inside, and a 7-sided figure has 5 triangles. Fix that triangle just a little bit. Cool. So you actually see a pattern here? And I do. And that pattern is this. Hey, the number of sides of a figure minus 2. Well, if I take the number of sides of a figure, let's just call it n, an n-gon, minus 2, and multiply this by 180, I'm going to get the measure of the angles on the inside. Cool. So would that hold true over here as well? So 8 minus 2 would give me 6 times 180. Is that what I used over here? Absolutely. So it looks like this formula right here can help me find the measures, the angles inside of any polygon. But the cool thing about the formula here is if you forget about it, just go back to the previous step. You can always create as many triangles as you can using a line segment by creating as many triangles as you can based off that one vertex, creating as many triangles as you can inside of the polygon. Cool, so you have 2 different methods to solve for this problem. The formula saves a little bit more time, and in fact, what I'm going to do is just to separate it from everything else, just highlight it with a different color. Give it some pizzazz. Cool, so let's go ahead and actually solve for a couple of other problems here using that formula. And we're not going to draw any lines up. In fact, all I'm going to do is use the formulas that were given previously, and it should give me the measures of the angles on the inside. So here I have a regular 10-sided decagon. And over on the other side, well, I've got a regular dodecagon, which is actually 12 sides. Cool. And let's use that formula again. It is, I'm going to change colors here. N minus 2 times 180. But before jumping at 100%, let's just backtrack a little bit. I noticed I put an extra A there. Just regular. And what does the term regular, and this is a regular dodecagon, what does that term regular actually mean? It's telling me, hey, all of these sides are equal, and all of the angles are equal as well. Well, let's look at this figure, the decagon, and since I have 10 sides and angle measures that are equal, what I could really do here is say, hey, I've got 10d degrees, which equal, and that's where I'm going to throw my formula in here. Let's fix these equal sign. They equal, well, they equal n minus 2 times 180, or remember n equals the number of sides, so 10d degrees equal 10 minus 2 times 180. Well, 10 minus 2 is 8. 10d equals 8 times 180, and 8 times 180, that actually equals 1440 degrees. So 10d degrees equals 1440 degrees, but I've got to isolate the variable d. To do that, get rid of multiplication, divide by 10 on both sides. Well, that gives me d equals, changing colors again, 144 degrees. Cool. Let's move over to the other problem. Let's look at the dodecagon. Now remember, since this is a regular dodecagon, all sides are equal, and all the measures on the inside are congruent. I'm just going to scroll up a little bit for now, just so the formula is visible. Cool. So since I've got 12 sides, since they are all equal, I can really say, hey, 12g. You know what, guys, before I even move forward from here, one thing I talk to my students is about separating problems out. That way you don't mix them up with the other problems. So I'm just going to draw a line straight down the middle here just to say, hey, and I'll even border this off. Say, hey, this is one problem. I got one problem over here that is solved, and I'm going to solve my second one over in this direction, but I don't need to border it off until the end. So let's get back to work. I could say that 12g is equal to, I'm going to call that degrees here, equal to, well, n minus 2 times 180, or I could have done the reverse here, and let's just do that as well, just to say, hey, it's okay to do this. I could say, hey, oops, there we go, 180 degrees times n minus 2. Well, n is the number of sides. 12g degrees equals 180 times 10. 12g degrees times 10 is going to be 1800. And since I've got 12, I want to isolate the variable. Since I've got 12 multiplying into g, divide both sides by 12. These will cancel. I believe 1800 divided by 12 should be 150, and let's take a look there just to verify it. I can pull my calculator over. Actually pull out the silver version here instead. Say, hey, 1800 divided by 12. Yeah, 150 degrees. Cool, and now that I have actually finished the problem, go ahead and border it off.